Okay, so today we'll go into a new topic, matrices and system of linear equations. Okay. Okay, so given an equations, okay. So do you think that this is a linear equations? Yes, right. Okay, all the power of x is 1, right? So this is a linear equations. So how to solve this linear equation, right? In order to solve it, we need another two more equations. Okay. So in order to solve it, we need three equations here. So these three equations will form a system. So we call this as a system of linear equations. Okay. So basically, this is a system of linear equations. So for this chapter, we're going to learn how to solve the system of linear equations by using different methods. So in order to solve this system of linear equations, according to the computational method, we need to convert into a matrix form. So the first matrix form is A times X equal to B. So what does it mean? A times X equal to B, right? So all the A here basically they are constant, right? So we call it as a coefficients. So all the A's they are constant, so we call them as a coefficient. So this matrix A basically consists of all the coefficients. Okay, and then the X basically is a variable. So it's a vector S1, S2, S3. Okay, and then B is the right hand side. B1, B2, B3. Okay, so sometimes the question may ask you to write down. So basically, this is a coefficient matrix. The question will ask you to write down the coefficient matrix, which means write down this matrix. Okay, this matrix. So in order to solve it, so normally we convert it into an augmented matrix. So what is an augmented matrix? So omega matrix basically is a coefficient matrix. Okay, together with all the b values. So together with the b values. So this is an omega matrix. So from the omega matrix, we can use different method to solve it. So the first method is Gaussian elimination. Second method is Gauss-Jordan elimination. So did you learn before? Yes, right. Third method will be LU factorization. LU you learned before? And fourth one will be metric inversion. Okay, so we will go through one by one. Okay. So before that, for these four methods, they are using the elementary law operation. So what does mean elementary law operation, right? ERO. Okay. So let's go through elementary law operation first. So elementary law operation, the first operation is interchange. Okay, two rows. So for example, so given an omega matrix 0, 3, 1, 4, 2, 5, for example. So row number 1 we call it as a R1. Okay. Row number 2 we call it as a R2. Okay. So now we want to do the interchange, R1 interchange with R2. So how to write the interchanging, right? R1 interchange with R2. Okay. So as a result, R2 will be on row number 1. Okay. And R1 will be on row number 2. So this is the first elementary row operation. Okay. Interchange two rows. And then row reduction, second one is. So row reduction basically is the addition of two rows. Okay, take one example. 2, negative 2, 4, 5, 3, 4. For example. Okay. So now we take R1, row number 1 plus row number 2 and produce a new R2. Okay, produce a new row number 2. So the row number 1 remain unchanged. Okay, so how to get the new row number 2, R2? Okay, so here will be 0. 2 minus 2, right? 0. Here will be 4 plus 5 equal to 9. Okay, R1 plus R2, R1 plus R2. 3 plus 4 equal to 7. Okay, so this is a very simple example of row reduction. Okay, so now we will go into first one. the first method, okay, first method, Gaussian elimination. Okay, so for Gaussian elimination, you need to pair with back substitutions. Okay. So let's go through Gaussian elimination. This A to be simpler. Okay, this index I never put in first. Okay, so the index basically based on here, 1, 1, 1, 2, and so on. Okay, to be easier, you can ignore it first. So here will be B, right? Okay, so this is an augmented matrix. So for Gaussian elimination, we need to turn this matrix into row echelon form. Okay, row echelon form, REF. Okay, row echelon form. So what does it mean row echelon form, right? So basically this is, sorry. Okay, so basically this is a row echelon form. Here is 0, 0, 0. Okay. So what does it mean row echelon form, right? Row echelon form is below the leading entry. Okay. All the elements are zeros. Okay. Okay. So what does it mean, right? So first of all, what does it mean leading entry? Leading entry. What does it mean leading entry, right? Let's go through this leading entry. So leading entry basically is a first non-zero element in a row. Okay, the first non-zero element. For example, this is the first row, right? The first non-zero is this one. So this is leading entry. Okay, this is a leading entry. And then for second row, the first non-zero is this one, right? This is the first non-zero. This is a leading entry. And for the third row, okay, the first non-zero is this one, right? So this is a leading entry. Okay, so under these leading entries, all the elements are zero, right? All elements are zero. All elements are zero. And under this leading entry, if there are elements here, okay, they will all be zeros. Okay, so this is a row echelon form. Below leading entry, all the elements are zero. Okay or not? Okay. So let's take two examples. Okay, to be clearer, take two examples. Okay, so let me ask you all. So do you think this is a row echelon form? Yes, right. Okay. So this is a leading entry, under leading entry all are 0. This is a leading entry, under leading entry all are 0. Okay, leading entry. So this is a REF, raw echelon form. How about second one? Now Y. Yes, okay. So this is a leading entry, right? But under this leading entry here is no 0. Right? There's no, again, non-zero. So this is not yes. Okay. So from raw echelon form, once we get the raw echelon form, we can use the back substitution to solve it. Okay. So from raw echelon form, we need to plus back substitution. Then only we can get the answer. So let's see how to use the back substitution. Okay. To solve the raw echelon form. So basically this is S1, S2, S3. Okay. So 3 times S3 equal to 3. Okay, along. So this column represent S1, this column represent S2, this column represent S3. So 3 times S3 equal to, right hand side equal to 3. So as a result, S3 equal to 1. Okay. And now move on. Okay, back substitution is mean we do from the back, from the last row. Okay. Then move on to second row. 2 times S2 plus 3 times S3 equal to 2. So S3 we have found out. So we plug in 1. Okay. So as a result, will equal to 2 minus 3. So 2 minus 3 equal to negative 1. So S2 equal to negative 1 over 2. And then move on to first row. 1 times S1, 2 times S2, 3 times S3 equal to 1. Right. So S2 and S3 we have found out. So just plug in. Okay. So cancel off, we get negative 1. Okay. So 2 as a result, S1 equal to negative 1. Right. So this is a back substitution. Okay, so from raw echelon form, we can use a back substitution to solve it and then find the solutions. Okay, so for today, quiz number 1, very simple one. Okay, so use back substitutions. To find S1, S2, and S3. Okay, do it now. Do it now. Okay, so the first column represent S1,
先
second S2,
最近
third
有观察
S3.
已经说到 S 的一声，后来有20。